Welcome to the Mission Minded podcast, where we dive deep into Scripture and ask ourselves what it means to live out the Great Commission. Let's jump into today's episode.
Hey everybody, and welcome back to the Mission Minded podcast. We're so excited to be recording again since we've all been having a very busy and fun summer. But from our last episode, we kind of left off with this cliffhanger of talking about the mid-oceanic ridge and talking about how the waters were separated by this thing, and there was water being divided by water. And so we just wanted to pick right up where we left off and answer some of the anomalies that come with the hydroplate theory, and then we'll keep going from there. So Dr. Anstein, do you mind kind of starting off with the mid-oceanic ridge and explaining, like, what does that mean that the waters were separated between the waters in Genesis 1:6?
So here's the thing. If just to remind our listeners that you know we're any kind of a historical science is going to be storytelling. It's going to be one of those that we're just going to reconstruct the pieces of a crime scene, if you will. You know, like forensic scientists would do. And so what we have to do is we have to look at the Earth, and we have to, I would argue, we're going to look at the inner planets and the outer planets of the solar system and say, okay, there are some distinct features that our story, if it's a good story, should be able to, explain very well. And so we left off really talking about the mid-oceanic ridge. We talked about this whole thing, the rakia, this firmament, if you will, between the waters that separate the waters from the waters in Genesis 1, verse 6. And so what we're going to do today, or what we're going to do in this podcast, is we're going to break down 9 anomalies and say, okay, if this hydroplate story, right? And again, back to the basics. If it's predicated on gravity, the main driving force for the hydroplate theory, the hydroplate story, is gravity. It's not thermodynamics. It's not heat, which is going to be plate tectonics and catastrophic plate tectonics that we already talked about. So when we look at these competing stories, we want to say, okay, which one of these stories does answer these anomalies the best, right? And so, and by the way, just the person that really wants to geek out on this, I would argue there's probably 40, closer to 50 anomalies that this story does answer and should answer. But for the sake of not boring our audience, we're going to pull up nine of the main ones that are really important if this is a good story. And we're just going to assess, does a gravitational model of the flood narrative actually explain these anomalies? Okay. And so the first one, Rachel, that you hit on was the mid-oceanic ridge. All right. So number one is going to be this idea of the mid-oceanic ridge. So what we have to remind ourselves, the mid-oceanic ridge is the largest mountain range on planet Earth. It roughly stretches for about 40,000 miles. The hard thing about the mid-oceanic ridge is it's underwater. So we don't see it. We can't go climb the mountains and climb down into the valleys. But the canyons that the mid-oceanic ridge has are 2 to 3 times bigger than the Grand Canyon. So these are massive canyons under the water.
So is it more like a trench? Like, is it more like a trench where it goes down, or is it mountains where it goes up?
It's both. It's both. I don't know if you can see that, but if you start over here, kind of in the Pacific area, you can see down below, just off of Mexico there.
Yeah, like it looks more like mountains.
Yeah, that's more of a mountain. And then as it goes down underneath Australia, you can see how it kind of stretches, comes up by east of Africa and Asia, and then around the Cape Horn there under Africa, and you can see how it comes back up into the Atlantic. So that and if you think about it in a 3-dimensional model, it roughly looks like actually the threads of a baseball. Okay, so you think about how the threads go around the baseball, and that's roughly what the mid-oceanic ridge does. So to your question, Rachel, it actually is both mountains and canyons, and the hard part about the mid-oceanic ridge is the fact that the way that the ridge forms, it's not like your typical mountains that spring up. It actually, like, it severs. It's a really unique pattern, and it's very difficult to understand how that happened if the Earth is only moving. If the plates are only moving at about the rate of your fingernails growth and these types of really slow processes, how then did water carve out these massive canyons? And you're running again. you run into problems, and you have scientists who say, well, it might have, well, it could have, and maybe, and so you start in the storytelling, you start to end in areas where someone like me who loves science and just says, you know what, this story just seems like it's off. There seems like we have so many like it might have, it could have, maybe, that we don't really have a good story. And that's where I would argue the gravitational model, the gravitational story of the hydroplate actually is a much better. We don't have the, well, it might have, it could have, it sort of did, as we're going to see with these 9 anomalies. And then when we finally get into the 4 phases of the hydroplate, you're going to see that it actually does a very good job of just logically and I would argue biblically and just scientifically does a very good job without a bunch of miracles or magic, right? And that's what I'm not a big fan of, the miracles of catastrophic plate tectonics. I'm not a big fan of the miracles of plate tectonics. I want something that's more tangible, and that's where I think the gravitational model really does shine. And one of the reasons why I teach it, I've written about it, and I go out and lecture on it. So and why we're talking about it here on the podcast.
Exactly. And so how does the hydroplate theory answer this anomaly?
Okay, so let's break down the anomalies. Let's go through the 9 anomalies that we're going to explain, and so let's just break it down. So the number 1 is the mid-oceanic ridge. That's where we start. Number 1. Now, if you go down to that second slide, that mid-oceanic ridge there. Now, this is a really important piece of the puzzle, so to speak. What happens with the mid-oceanic ridge is when you actually look at it in 3 dimensions, which this graphic is doing right here. Notice how the mid-oceanic ridge, and now we're looking at, if you look at this globe, it's 3-dimensional, it's a globe. You can see the redness there is going down between South America and Africa. Notice how the mid-oceanic ridge runs almost right in the middle of those 2 continents. Okay, that's very important because once again, our story, if it's a good story, needs to explain that. All right. So we're going to work on can a gravity model explain that and how and if so how. And we'll get to that. Now, the second anomaly is the continental shelves and slopes. All right. So this is a really cool feature of all the continents, and so all the continents have this very unique structure in that when you actually look at the actual the shelf and the slope here, you can see that there's this really shallow shelf that goes out and then it just drops off. Okay. And I just a couple weeks ago was out fishing over where it actually does drop off into the really deep thousands of feet. All right. And so this is a feature. And if you go to the next graphic, you can see that it's not just one place. Every single place that the continents come up out of the water, they have that continental shelf and they have that continental slope. So that is an anomaly that is actually a feature of all of the continents. And so once again, our story, if it's a good story, needs to explain that. Okay. The third anomaly is what we call Pangea. Now, if you have had any earth science back in the day, or even some of our modern college textbooks have these graphics, you can see that the concept of Pangea is that at one point in the history of Earth, there was this massive supercontinent. And over time, very slowly, the growth rate of the fingernail, those continents from subduction and convection, all this thermodynamic move to where we have today. So you see it before and after. So one of the things that's kind of comical about this graphic is that it's actually not in scale. It's an artist rendition. And so I always ask people, it's kind of like you see the front side of Mount Rushmore, what's on the back side, right? What's on the back side of the Pangea? Well, there's a lot of water on the back side of that because there's no continents, right? And so it's just the graphic itself is kind of funny, but what you're not told is that when you look at the before graphic there, the before Pangea graphic, Africa is actually shrunk by about 40%, and so that's kind of again artistic rendition of a story that's not very, it's great, it's great, it's pretty graphics, but it's not realistic graphics,
not super accurate.
No, and the other thing you'll notice there that Africa actually as a continent, even on this graphic, has been rotated clockwise, and so that's a very difficult thing to do, is rotate. They're
like, how can we make it fit?
Yeah, exactly. Right. What can we do in Photoshop to get this thing to fit? And so you end up with this concept. So what I'm going to argue is if there is a better story, if the gravitational model through plate tectonics is a better model, can we explain the after? Let's forget Pangea as this comical graphic, and can we come up with a model that actually explains what you see on the right there? So here's why this is important. When you actually see the Pangea here on the left actually made into a paper mache model in 3 dimensions, notice if you make the model not to what's out of the water, but to the continental shelf and the continental slope, notice the graphic on the right is exactly that. And you can see how the paper mache model of the continental shelves and slopes in 3 dimensions, it's a close fit, but it's not a perfect fit.
Yeah, like there's some holes.
Yeah, there's some gaps, right? There's a gap there between Africa and South America. So what I want I want our listeners to actually really think about and question is, okay, how could that have formed, and can our story explain that? Because this is really important. This is where I think our theory, the theory that I'm going to propose, actually really shines is in answering this. Okay.
Yeah, because you can make all of those continents fit really well if they're on 2 dimensions, but if you're at a 3 and there's all that texture and stuff.
Right.
And it doesn't quite line up.
Correct. Now watch what happens while we're talking about this. Watch what happens. So the next graphic is a reminder of the mid-oceanic ridge. Now watch what happens when we take that paper mache model, and instead of bumping them to one another, we bump them to the mid-oceanic ridge. Watch what happens. And so this is a model. Notice the mid-oceanic ridge runs right down between the paper mache model of the 3-dimensional continents when we take into account their shelves and their slopes. Does that make sense?
Oh, yeah.
Mm-hmm. Yeah.
And that looks much more accurate to like what our Earth would look like right now, too.
Right.
Correct. And so now you see the mid-oceanic ridge, and for some reason it looks like it's kind of down in between these 2 continents, and to me it looks like, well, maybe there's something missing. Maybe it looks like we're actually missing part of the paper mache structure, right? And that's what we're like, okay, where did it go? What would have released that, or where would that have gone? And that's what we want to try to address in working through this. Okay, and so our next one is 4. It's what the consistency of the actual what the actual continents and the ocean floor is made out of. This is a very important, and this gets technical and very kind of geeky in the actual types of compounds that we're talking about. We don't need to do that. But what I want our listeners to realize is that the continents are made out of roughly a compound called granite. Now, granite to me is kind of an anomaly. It's kind of an enigma. It's not something that we can just duplicate in the laboratory super easily. It has a really unique profile. But notice that the continents are all made out of granite, and the ocean basins are made out of basalt. Okay, now that's a very important thing. So basalt is an igneous rock, and granite is a non-igneous rock. And as I said, this is a chemistry thing. We don't need to get into the difference between that. But notice that they are different. The ocean basins, what the floor of the ocean is made out of, yes, it has some layers of dust and dirt and mud, but below that is a what we would call the basaltic plain, and it's made out of basalt. The continents are made out of granite. Once again, granite, if you go back to Genesis 1:6 is where we're going to talk about that firmament that was pounded out between the waters above, and it separated the waters above and the waters below. That's a very important part of what's going on. And I'm going to argue that what separates the water from above and the water from below is this layer of granite. Okay, that's very important, and we'll come back to that.
Cool.
Okay. So, and then that gets us to anomaly 5. And anomaly 5 is really the location of the major mountain ranges. This is something that we, once again, this is a flattened out 3-dimensional globe to 2 dimensions, so it looks weird. So Iceland looks weird and Antarctica looks weird because you're taking 3 dimensions and you're kind of flattening it out, so it's all warped and distorted. But what you can see by this graphic, nonetheless, is the red on this graphic is the actual locations of the major mountain ranges. And so with that, you can see that where are the Rockies and the Andes, right? They're all on the west side of North America, Central America, and South America. And you can see that red is all of the major mountain ranges, the real tall peaks The tallest peaks of South America are in that red. The tallest peak in North America is in that red, right? So you see all the mountain ranges are on the west side of those two continents. When you get over here to Asia and Africa, where are the tall mountain ranges? Well, they're on the east side. They're on the opposite side as the North American the American continent. Does that make sense? That the major mountain ranges are on the east side of Africa and Asia, and they're on the west side of North America and South America. Does that make sense?
Yeah, so they're opposite. Yeah.
They're on opposite sides, right? And here's what I'm going to I'm going to tease our listeners. Notice they're on opposite sides. They're away from the mid-oceanic ridge in the Atlantic Ocean. Isn't that kind of interesting? Yeah. So you can see how the mid-oceanic ridge, once again, it's there in this graphic. It goes down between the Americas and between basically Europe there and Africa. You can see it down there in the blue. But notice the mountain ranges are on the major mountain ranges on the other side, away from that Atlantic part of the mid-oceanic ridge. Okay, so once again, our story needs to explain that. Okay, now anomaly 6 is actually pretty fascinating. This thing that we call hemispherical asymmetry. This is where I think the hydroplate theory gets fun because it doesn't just delve into terra firma, good old Earth. It actually starts to go outside of Earth, and this is really cool because plate tectonics isn't going to deal with the moon. It's not going to deal with the outer gas planets. Plate tectonics shines in that it also is going to help us understand some amazing things, and again, once again, challenge us to think about the story of our solar system, not just Earth itself. So when you talk about hemispherical asymmetry, when you look at the moon, what we're looking at in this graphic here is what we call the near side. There's the near side of the moon and the far side of the moon. And the term hemispherical asymmetry means the near side and the far side don't look the same. And so when we look at the part of the moon that we see these massive craters, and not only that, but the kind of the darker gray smudges over there on the left side that when we look up at night, it looks kind of like a bunny rabbit. Those are actual anomalies at one point in the past of the moon's history. Those were very hot, very, very thermally active regions of the moon. And so right now, when we look at the moon, running about 4 or 5 Kelvin, it's not very warm out there. How did that get hot? What slammed into the moon to cause it to heat up? And then all those pock marks and all those craters that we see, the backside has a very different profile, but there's an asymmetry to it. And I'm going to argue that a good story should be able to explain that, and this is where, once again, a gravitational model through the hydroplate theory does a really good job. Okay,
is the other side of the moon more like smooth than all the holes and stuff?
It's smaller pocks. It's actually, we don't have a picture of it because it's dark, but it's smaller craters. There's also craters on the other side of the moon, but it doesn't have this profile.
Okay.
Okay, gotcha. So that's where the asymmetry comes in, and so if you go to the next graphic, you'll see it's not just the moon; it's also the inner 3 planets. So there's the inner 4 planets and the outer 4 planets. So you have the inner 3 planets of Mercury, Venus, Earth, and Mars. And so with those inner 4, obviously Earth is one we're talking about, the one we're going to be concerned with. But notice how Mercury down there in the bottom right also has this anomaly of these pocks, and Mars does, and Venus. So it looks like the smaller inner planets at some time in their past had massive disruption in something slamming into them. Okay. Now, here's what's really cool. When you go out to the outer 4 planets, number 7 is going to be the fact that the outer 4 gas planets, so you're going to have Saturn and Jupiter, Uranus, and Neptune, all of those have rings. Now, Saturn, of course, is the most dominant. Saturn's the one we take pictures of when we look at it because it's like the rings of Saturn. But notice Jupiter, Uranus, and Neptune also have rings. And the rings are made out of, which is something that we have to really understand and maybe explain with our model, with the story. Those rings are actually made out of rock and ice. Okay, and so the question is, why are they there? Can our story explain how they got there? And kind of what's going on with them. And if you go out past the rings, you get to anomaly 8, and that's going to be the Kuiper Belt and the trans-Newtonian objects, the TNOs. Outside of our solar system, notice you have the Kuiper Belt out there. And the Kuiper Belt, which is that graphic on the far right, kind of obviously an artistic rendition. Those chunks that are floating around out there, the biggest of the trans-Newtonian objects is a planet that I grew up talking about, and that was Pluto. Pluto was voted as not a planet, but the largest of the TNOs, the largest of the trans-Newtonian objects. So I knew it as a planet. It's now just considered a big giant TNO. But here's the funny thing. The Kuiper Belt and all those TNOs out there in the Kuiper Belt, guess what they're made out of?
Rock and ice.
Rock and ice. Okay, so...
And what is the Kuiper Belt?
The Kuiper Belt's just a bunch of rock and ice floating around.
Gotcha.
Yeah. And like I said, if anybody really wants to get into this, you can actually look at some really cool things in the Kuiper Belt as far as the way that some of those objects rotate, the way that what they're made out of. They're not made out of big hunks. They're made out of small rocks that have come together and form these bigger. So if you bump them, they actually fall back apart. They're very interesting. Once again, I would argue that a good story needs to explain that. And so...
Okay, this might be a stupid question, but
great.
Is the Kuiper Belt different than the Milky Way?
Well...
Or is that too complicated?
No, it's part of the Milky Way. The Milky Way. Okay, that's a good question, actually. So when you have the inner 8 planets, right, and you look out and you kind of see this. The Milky Way is more of a visual that we call, but it is celestial bodies, right, that have different names or whatever. And again, it gets more into the astronomy that I really want to get into. But for the most part, the answer I'm just gonna do a blanket yes. There's aspects of what you would consider the Milky Way to be part of those TNOs and part of the Kuiper Belt and what we're looking at when we look out there. But
gotcha. Sorry, don't want to derail the.
No, it's a great question. It's a great question, and
the podcast with my silly question.
Yeah, and it's kind of a sort of, because exactly what we're looking at. One of the interesting things of what we're actually looking at when we look out at space, are we actually seeing reflections of objects, or are we seeing actual objects that are burning and have their own source of energy? It's a very different. That's why I'm saying it's a kind of a sort of. It's not a.
Yeah, it's going to be too deep for today.
Yeah, and we can pick that back up, but I don't. Yeah, for today, that might be a little bit of a tangent we don't necessarily want to go down, but we can at some point if we want. Okay,
no
so, and that's actually Rachel, a good segue into anomaly 9, and that's going to be what do we do with comets, asteroids, meteorites, and meteoroids, and so with this. We have these comets that we look out and they have a certain Halley's Comet, and some of them have names because they have a certain periodicity where they come back every X number of hundreds or thousands of years or whatever it is, decades or millennia, and so or century, I guess it would be. So with that, what are they actually made out of? Well, here's the crazy thing about a comet. Comets are not on fire. Comets are actually just big, giant dust clouds that are circling at a certain periodicity around the sun. And so when you see an actual comet, you're actually seeing the reflection of the sun's light. So they're not on fire. They're actually just reflecting the sun's the sun's light. And so the question that and they're actually made out of, guess what? Rock and ice, right? And so the question is, where did they come from? Because there isn't a really good, other than maybe there was an explosion between Mars, some kind of a fictional planet between Mars and Jupiter, where you get the asteroid belt, so to speak. Maybe there was a planet there that exploded, and that's where they came from X number of millions of years ago. The problem that we run into with that is they are losing their energy every time they go around the sun. And so they're getting slower and slower and slower. And and they're actually falling apart. And so they don't last. When you extrapolate that back, they're actually fairly recent to our solar system's existence. They're not tens of millions, hundreds of millions of years old, because there wouldn't be anything left with the way that they're falling apart. So that they're kind of an enigma, an anomaly. How do we explain them? What's a good explanation? And once again, I would argue that a good story is going to help explain where those come from. Okay, so let's review the 9 anomalies. Then that's our next slide, and that's going to be, the mid-oceanic ridge, the continental shelves and slopes of the continents, the jigsaw fit, the granite and basalt structure of the actual continents and the ocean plain, the location of the major mountain ranges, again on the west side or the east side depending on the continent, hemispherical asymmetry on the inner three planets and the moon as well. The outer rings, all of them have those big gas giants, have those outer rings, all made out of rock and ice. And then we get to the TNOs, comets, asteroids, and meteorites. Okay, so here's the cool thing. When we look at those 9 anomalies, okay, what we're going to do basically with plate tectonics is going to stop at anomaly 5, right? What I'm going to argue is if we understand through the biblical lens, the logical thinking, and we bring in good science, we're going to have a story that actually does a very good job of explaining all 9 of these without, like I said, miracles or magic. That to me is one of the reasons why I really do like the hydroplate theory once again in more of a forensics idea of science, of putting a catastrophe, a train wreck or a crime scene back together, because we weren't there. But what we can do is just say, okay, who was there, right? We talked about this with eyewitnesses, and that's what I do believe. Moses wrote down in Genesis what eyewitnesses would have seen through Noah and Ham, Shem, and Japheth, his descendants. Okay, so what we have in Genesis 1:6 and Genesis 1 basically through 6 or 7, those are going to be eyewitness accounts of what happened, and I do think those are credible and accurate.
Can I stop us there for a second and
Absolutely.
just kind of recap everything we talked about, because that is kind of a lot to digest.
Right.
So all these 9 anomalies, we're calling them, that we just talked about, are essentially, each of them is kind of something in our planet, in our solar system, that's kind of tough to explain, especially when looking at creation narratives. And so we just went through each one of them, kind of giving a synopsis of them. And now we're kind of looking at how the plate tectonic theory, which is like the predominant creation story, kind of how our world came to be, can really only answer 5 of these. And we're talking about how the hydroplate theory, another creation flood narrative, actually answers all 9 of them rather than just half of them. Is that correct?
Correct. That's
okay,
correct.
Awesome.
That's correct. And once again, what I would argue, Bella, that's a great just clarification. When we actually talk about plate tectonics, we talk about plate boundaries, we talk about subduction models of how did you actually, I don't know if you remember the kind of the visual that I gave, but when you look at plate tectonics says we have this big giant layer of crust, right, granite, it broke, and somehow that it went under and started to go under. So these continents start then to move under one another. And the boundary zone is where we get the earthquakes and things like that. Okay. The problem that you're going to run into with plate tectonics is the mechanism to get that much granite, which is floating like a life jacket, to go under the boat and push under it. It's really difficult to do from a thermodynamic, from a heat model. So that's where I'm arguing those 5 anomalies that we see up through anomaly 5 on our list. I think there's a better way, and I'm going to argue there's a much better way of understanding this than a thermodynamic model.
Okay, gotcha.
And then I have one last question before we move on too. So you just mentioned how in Genesis 1:6 you feel like that is one of the eyewitness accounts that, like, because Moses is the one who wrote Genesis, correct?
Correct.
So, like, are you saying that, because obviously Moses wasn't there at the creation of the earth, but are you saying that because he was a part of the flood and he, like, saw the flood as an eyewitness account, that he can, based off of, like, the inspiration from the Lord, like, understand how to, like, write the word so that it is like an eyewitness account, kind of?
Yeah, so and and it'd be fun to actually do a podcast possibly on the historicity of Genesis. That could be its own, its completely own standalone. What I would argue, what I would push back against, and one of the things going back to our other podcast, I actually think and believe quite strongly that the first 11 chapters of Genesis are actually historically accurate, and that's going to be very juxtaposed to a lot of theologians. I shouldn't say a lot, theologians who who make it more allegorical or mythical. They don't say that it's actually true handed down history. Because I personally, if you go back and look at the great ages of the patriarchs and Methuselah being 969 years old, and there was a you can actually, Methuselah would have known, remembered Adam, right? And so you have this overlap of the patriarchs because of their great ages, that all of these historical anomalies or these historical events would have been handed down by oral tradition. And I would argue that oral tradition was a phenomenal way to hand down truth, and they would have told it through the stars, and that's where we get some of our, I don't like astrology because it kind of got off onto worshiping it, but when you look, you can actually see the some of the great pantheon of the gods up through the stars, like Zeus and kind of these Jupiter and all these kind of funny things. There's something going on there that the oral tradition, I believe, was handed down all the way to when Moses actually pens it, so to speak, or chisels it, whatever you want to say. But it was definitely historically accurate. So that's why when I see Genesis 1:6, I actually do think that there was actual wisdom and eyewitness knowledge of what was going on through some level of knowledge of the creation event.
Interesting. Okay.
And that goes back to when we talked about the three rebellions, right? Of Genesis 3, 6, and 10 or 11. You have to realize that those are all, I believe, those are all historically accurate falls, right? The Adamic fall, the Watcher fall, and then the great Babel rebellion. Those are all historical events that I would argue that Jesus restores when he goes to Bashan and Mount Hermon. So once again, I think Genesis, to me, becomes a very clear and rich book when we deal with the unseen realm. And now I would argue, as a scientist, that it's actually doing a very good job of giving us a background of what the earth would have looked like prior to the destruction of it, right? And this is the thing with forensic science. Forensic science is trying to put together a crime scene or a automobile accident, and all we have to do is we look at the earth, and there's an assumption. Here's a different way of thinking about the earth. The plate tectonicist is going to look at the earth and say it's always been this way, nothing went wrong. But when we read the Genesis accounts, like, no, the earth was destroyed. Go back to, remember, Peter says the earth was created, the earth is going to be destroyed. And in the middle of there, he says the flood is what destroyed the earth. And so what's happening is I'm arguing that we have a destroyed earth. This isn't the way the earth was supposed to be, or the way the earth was at the end of Genesis 1 or Genesis 2. Something happened to the earth. And so to me, these 9 anomalies, going back to Bella, these 9 anomalies are anomalies that are of a crime scene or a automobile accident. So now what I'm going to say is there a way that we can put the story together as to what might have happened to explain these 9 anomalies?
Okay, yeah, that makes way more sense. Also, maybe it'd be cool if we did like a Genesis series after this and like the Unseen Realm and stuff. Because I just started reading The Unseen Realm by Heiser, I think is. Yeah, and I'm only on like the 9th chapter, but man, I'm like learning so much and it's so interesting. And I feel like it would help, and especially since, are you done writing your book on Genesis?
I have it. Yes, I'm not done, but I am.
We're close.
I'm into chapter like 7, but unfortunately it's become 24 chapters. So it's become a magnum opus. It's not going to be, I don't know, I'm not like 300,000 words. It's going to be massive.
Oh
so
my gosh.
Because I want to do it right. I don't want to do it just, I don't want a thin version of scholarship. I really want to show, and what we're talking about with the Hydroplate, with the flood, why the flood, right? The only reason why that we had the flood in Genesis 6:5 on, is because we had the Nephilim or the Watchers messing things up in Genesis 6:1-4, right? So to me, the unseen realm and the flood, they have to go together. They're not separate events. One is because of the other, and so that's why, to me, the science of the Hydroplate theory then brings in the beauty of what happened with this crazy catastrophe that we call the flood of Noah.
I just think like studying all that would totally help tie a lot of this more together for everybody who's like still a little bit like unsure about everything.
Oh,
but
sure.
Anyway.
Sure.
Yeah.
And that's, I love it when my students are like skeptical and like, I don't know about that. Great. Keep studying. Don't take be like the Bereans, right? Study the things you're told, see if they're true. And so I love that idea. Don't just take my word for it, because I came into the Hydroplate model, this gravity model, kicking and screaming. I didn't just accept this. I've been studying this thing for almost 30 years. And I've had conversations with Walt Brown, who actually proposed it, and he passed away. He passed away last fall. But it's something that I didn't just accept willy nilly. Like, hey, this is cool. This is something I wrestled with, and I'll just tell our listeners that what we're going to propose here in the gravitational model, it is the absolute best explanation for the periodic table. Period. It nails the periodic table and the heavy isotopes, and so it's just fascinating. This, like I said, there's way more anomalies than just the 9 we're talking about. So.
Mm-hmm.
Exactly.
Well, to get us a little bit back on track, what we were talking about.
Thank you, Bella, for both of us.
Sorry,
who probably have ADHD.
So, Dr. Ensign, you wanted to dive into like how Hydroplate kind of answers these anomalies. Is that something you want to dive in right now, or do you think we should like separate into different podcasts?
No, I think let's just move on. Let's just move right on down the slides there, Bella. Notice on your computer, and let's just take those 9 anomalies. And I want to remind this is so before we propose the model, before we see the gravitational model that is the Hydroplate theory, I want to remind our listeners that when we're talking about the Earth, this is a very important graphic to remind ourselves of. When we're actually looking at the Earth in its massive size and scale, the crust of the Earth is on average about 30, you can say all the way up to 60 miles thick. So hear what I'm saying there. The crust of the Earth, well, we're going to be talking about this granite layer, the crust. It's about the thickness of an apple skin to an apple. Okay, that's really, really important for our listeners to have that mental picture. So when we're talking about the crust, and on this graphic, you see all the way over to the right, you see where it says crust there, right above the ocean there, the blue. So that crust up there, the upper right there, that crust layer is about the same thickness as the skin of an apple. So to the Earth, now to us, when we start talking about 30 miles to 60 miles of granite, and we're like, holy mackerel, that is a lot of mass. But to the Earth, it's not, right? To the Earth is actually, because of its size, its massive size, that's not that big of a deal for it. Okay, I just want to remind our viewers to put that in perspective, because what we're going to propose in the Hydroplate theory does seem like, whoa, you're talking about that crust actually breaking, okay? And so that's what's going to be pretty interesting about the proposal for the Hydroplate theory. All right. So with that, let's go back to Genesis 1:2. Let's go back and remind ourselves. We alluded to this in our previous episode. But in Genesis 1:2, it says the earth was without form and void, and darkness was on the face of the deep, and the Spirit of God was hovering over the face of the waters. Now, this word in the Hebrew, this mayim, is always liquid water. So we have water suspended over non-water, or water suspended over this solid. Now go down to the next verse. This is 1:6 is very fascinating to me. This is a very important verse. Then God said, let there be a firmament, this rakia, to spread or beat or hammer out. It's kind of like a metal plate is the word there you would have in the Hebrew. And so we put this in the midst of the waters and let it divide what? The waters from the waters. So what I want our viewers to realize is that the eyewitness account says that the earth was created with water. Then there was this firmament that was placed to separate out water from above and water from below. So that picture right there is the model that was given to us, again, by eyewitness accounts. So now if you take that model and you put it on a global scale, notice what you get. You get that picture roughly for the entire Earth. So you have this layer of water.
Oh, wow.
You have a crust, right? It's not to scale. It's the same one as we had there a minute ago. But then you have water above the firmament, and then water below. Now, over time, go to the next slide. What's going to happen is there's going to be a natural flow to this. And so you're going to have pillars. And when you look at scripture talks about the pillars that were let the waters under the heavens be gathered into one place and let the dry land appear. And it was so, and God called the dry land and the earth, and he gathered the waters and he called them seas, and God saw that it was good. So you have this idea that this firmament separates out now what we would call the pre-flood seas, where we have the deep, which is going to be again this massive amount of water that's underneath this granite. Think of it as like a pie crust, if you will, or think of it as a 2-liter bottle that's under an incredible amount of pressure. Okay, but that water is sealed in, and it's sealed in by that granite layer. Okay, now that's really important. So the next graphic, stop at this one. This is very important. So now here's the cool thing. This is the pre-flood world, right? I'm going to argue that this is what Earth looked like before the flood. It had these quote unquote pre-flood seas. They're going to be not nearly as salty as what we have in our ocean today, but there was a level of salinity to them because they're natural minerals that would make it salty, but mostly they lean more fresh than salt. Again, there's studies that can explain why it is that we had it that way, but that's what the biblical, I would argue, eyewitness account explains to us what the earth looks like. Now, this is where it gets really fun. Notice that when you have the moon pulling on that, okay, you have the moon pulling on that, and it's going to flex just like the ocean has its tides. Twice a day, the water in the ocean basin sloshes to the west coast and sloshes back over to Japan. The same thing's going to happen with that earth before the flood. It's going to flex this way, and then it's going to flex that way. And it's going to flex twice a day. The moon is going to pull on that pie crust, and it's going to move. There's going to be a dynamic flow to it. Okay? That's really important. So here's what we have. Now, this is really cool. There was a large storehouse of water, subterranean water, under the granite. And that water was increasing because remember, as the tidal pull is doing this twice a day, what are you doing? It's kind of like you're shaking up the 2-liter bottle, okay? And you're shaking it, and you're shaking it, and you're shaking it, and you're shaking it. And what's going to happen eventually when the pressure builds up enough, right? The pressure is going to be building and building and building and building and building and building, and eventually it's going to go and want to be released. And Here you go. And the Bible tells us in Genesis 7, in the 600th year of Noah's life, in the 2nd month, on the 17th day of the month, we know the exact day, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were then opened. Notice the word there, burst, I have in bold. That word in the Hebrew literally means like someone stomping on a ketchup packet. It literally means violently bursting. Okay, so on the same day, all the fountains of the great deep basically exploded, burst forth. And so go ahead and go to the next graphic, and we'll stop on this one. And notice, there you go. There's the best picture of that apple skin granite layer that was under an incredible amount of pressure on the same day. The very first event that we're told by eyewitness accounts of the flood was that it burst open. Now, when we get back together in our next podcast, we're going to see how all 9 anomalies are answered. And I would argue the next 30 to 40 anomalies that we haven't even talked about are all answered by that one event right there that you see. And because right there you can just see some of the anomalies that are already going to be answered, right? What happened to the moon? Well, the moon's going to get blasted by that, right? The Mercury and Venus and Mars are going to get blasted by that. The outer planets, as those projectiles of rock and ice are going out there, the big gas planets are just going to suck those in and put them into an orbit in the form of rings. And what they don't suck up, it's going to keep on going and make the Kuiper Belt and the TNOs, and some of the bigger ones that coagulate together are going to form comets. And you can just see this is a much bigger, robust understanding of really what happened to explain the solar system and planet Earth. Now, what's exciting when we get back next podcast, we're going to see that those 9 anomalies, or the first 5 of those 9, are perfectly explained by four phases. But I want to do an entire podcast on the four phases to show exactly how it is that those first five anomalies are spot on answered. Mid-oceanic ridge, the continental shelves and slopes, why we have basaltic plains in the ocean and granite in the crust, and all of that, the ocean, where the mountain ranges are, right? The concept of Pangea, it is beautiful in its explanation of how we put back together what I would call the crime scene of current planet Earth.
Man, this is so fun. I love studying this. And I would encourage you, if you're listening on Spotify or Apple, to go to YouTube to see these photos, because I feel like it just helps you understand it visually so much more. But I really like the image that we're currently on, because it's like showing that even, like, for example, the mid-oceanic ridge, like we'll talk about that in the next episode, but like if the fountains of the Great Deep burst open and it kind of like almost like ruptured like in that crust, which is kind of cool. Anyway, I just get so excited about this. This is so fun.
I'm with you, Rachel. I just was like, this. I geek out on this stuff because I love science, right? And it's so fun when science and logic and scripture come together, and not just like I said, not magic or miracles. This is just good science. It's logical and it's eyewitness account. It's just it speaks to a so precisely, right, to what I keep calling the crime scene of Earth, because it works. It works in a realistic model.
Well, and like at first I was like, what's the significance to him saying like, oh, in the 600th year, in the second month, and like all these specific like days? But I feel like it's because like in our lives, like if we want to remember something that's like super dramatic, like someone's wedding is like probably like the biggest day of their lives. So, like they're gonna remember the day that they were married, or like for example, there's like wars and things that have happened that people are like, oh, in this year, this was when this war happened. Like when big dramatic things happen, we remember it by the day in the year. So it's kind of like Moses is being like, whoa, you guys, this was such a crazy event and it happened at this time on this day, and like you can't forget it because this was wild,
Well,
like I feel like it's kind of like that.
And Rachel, this will blow you away, but there's actually good scholarship that says that on Tishri 1 is when Adam was born, on Tishri 1 is when Noah got off the ark, and Tishri 1 is when Jesus was born. So you've got this it's crazy how when you look back historically, that when you actually let the scripture speak, there's something amazing about Adam, Noah, and Jesus, right? They're all kind of linked together, and you start to see that specificity coming out of it. It just makes me excited that this isn't just haphazard book thrown together. This is a very historically accurate, life-changing. We can find the good life, the abundant life, because that's what we've been given through it.
Exactly.
Yeah.
Well, Bella,
that feels like a good as place as any to land the plane. I mean, I'm super excited for next episode when we can dive more into the phases of the theory. But I think we should call it wraps because I think we covered a lot today.
Right on.
Yeah.
Thanks everyone for tuning in, and hopefully we'll get our next episode out soon so we can finish up this part of the hydroplate theory.